So we'll look at another example of how chain rule is applied to find the derivative of certain types of functions. Let's start off with f of x equals radical x. We know that the derivative of f of x is 1 over 2 radical x. Now suppose we have f of x equals, and instead of x, I'm going to write a function of x. So let's say we have 1 minus 2 x squared. So instead of x, what I have here is a function of x. So what we have here is a function of a function. It's a composition of two functions. One of the functions is radical x, f of x equals radical x, and the other function is g of x equals 1 minus 2 x squared. So if we compose the two functions, we get f of x equals radical 1 minus 2x squared. So first we have to recognize that it is in the form of radical x, except that instead of x we have f of x. So here is how we're going to differentiate it using the chain rule. So the derivative of the function is, now we're going to pretend like that is an x. Okay, so if we have radical x, the derivative is 1 over 2 radical x, right? But remember that instead of x, we have 1 minus 2x squared, and that's what tells us that we need to use the chain rule. And how does the chain rule work? We multiply it with the derivative of the inner function. Whatever we pretended was an x is now differentiated. So now we have 1 over 2 radical 1 minus 2x squared. D by dx of this is 0 minus 4x, because d by dx of x squared is 2x. So this is equal to 1 over 2 radical 1 minus 2x squared times negative 4x, right? So let's simplify and we get negative 2x over radical 1 minus 2x squared. Next, let's look at another example. F of x equals radical x squared minus 7x plus 1. So this should remind us of f of x equals radical x, because that is the outer function. It looks like radical something. So now if we have to differentiate this, we pretend like all that is an x. And if it were an x, then we would go 1 over 2 radical x. But instead of x, we're going to write down the function of x. And that reminds us that we need to differentiate the inner function. This is the inner function. The outer function is radical x. We need to differentiate x squared minus 7x plus 1. So this is the chain rule. And this is equal to 1 over 2 radical x squared minus 7x plus 1 times d by dx of x squared minus 7x plus 1 is 2x minus 7 times 1, which is 7. So this is equal to 2x minus 7 divided by 2 radical x squared minus 7x plus 1. Now we have the next problem, which is f of x equals 2x plus 3, that's our first function, times radical 1 minus x squared, which is our second function. Notice that this is not a single function which is a function of a function. It's a product of two functions. So if it's a product, in order to differentiate the function, we need to use the product rule. So we have 2x plus 3 in parentheses d by dx of radical 1 minus x squared plus radical 1 minus x squared times d by dx of 2x plus 3. Next, we have 2x plus 3 times. Now we need to differentiate this function. And the function is radical 1 minus x squared. So it has to remind us of radical x. And that's the outer function. The inner function is 1 minus x squared. So we have to pretend first like it's a 1 minus x squared is an x, and we go 1 divided by 2 radical x. But instead of x, we have 1 minus x squared. We use the chain rule, which means we multiply with the derivative of the inner function, plus radical 1 minus x squared times d by dx of 2x plus 3 is 2 times 1, which is 2. So this is equal to 2x plus 3 times 1 minus x squared. We differentiate it to get negative 2x divided by 2 radical 1 minus x squared plus 2 times radical 1 minus x squared. We can simplify it a little further, but this is the derivative. So the first thing we have to do is recognize, is it a product? Is it a quotient? Is it a sum or difference? Or is it a single function? And based on that, we use the rules that we have learned.